Now we'll come to equation of a straight line. Now a straight line in 2 dimension, it is characterized by a linear equation ax plus by plus c equals to 0. Now in 3 dimension, this linear equation ax plus by plus cz plus d equals to 0, it doesn't represent a line. It actually represents a plane. So equation of a line in 3 dimension, it won't be a linear equation. If we have any linear equation in 3 dimension space, that equation is going to represent a plane. So in 3D, we'll study straight lines and we'll also study planes. Now a straight line, it is characterized by its direction. And a plane, it is characterized by a vector which is perpendicular to this plane, and we call this vector as normal vector to this plane. So if we have any equation which is ax plus by plus cz plus d equals to 0, these coefficients of x, y and z, they represent direction ratios of normal. So direction ratios of normal to this plane, they are simply a, b and c. We'll use this fact while solving problems in straight line. So if we are given equation of plane which is say 2x plus 3y minus 4z plus 7 equals to 0, then direction ratios of normal to this plane, they are 2, 3 and minus 4. So if we need any vector which is perpendicular to this plane, that vector is given by 2i plus 3j minus 4k. So now we at least know equation of straight line in 3D space, it won't be a linear equation. Then what does it look like? So now we'll actually start writing equation of line. Now this first equation is symmetric form. Now in the symmetric form, we'll be given a point on this line, say A, and that is x1, y1 and z1, and we are given direction ratios of this line. So suppose direction ratios are A, B and C. So we'll be given a point and we'll be given direction ratios, and we need to find equation of this line. Now any general point on this line, we can write it as x, y and z, where x, y and z, they'll vary. Now if we write direction ratios of AP, direction ratios of AP are x minus x1, y minus y1 and z minus z1, and these direction ratios, they are proportional to A, B and C. So from here we can write x minus x1 upon A equals y minus y1 upon B equals z minus z1 upon C, and this is equation of straight line in 3 dimension. So if we have to write equation of a straight line, we need a point and we need direction ratios. Then equation of that line will be x minus x1 by A equals y minus y1 by B equals z minus z1 by C, and this form is called as symmetric form. Now say for example, we have to find equation of a straight line which passes through the point 1, 2 and minus 3, and which is in the direction of a vector whose direction ratios are 2, 2 and 7. Now it is x minus x1. So we can write this as x plus 1, y minus y1, y minus 2, and then z plus 3 upon a, b, c. Now a is 2, b is 2 and c is 7. So this is the equation of this straight line. So all we need is just a point and direction. So from point and direction ratios we can write equation, and from equation we can write point and direction ratios. So if we express any equation as x minus x1 by A equals y minus y1 by B equals z minus z1 by C, where coefficients of x, y and z, they are 1, then the numbers in the denominator, they'll represent direction ratios, and if we put all of them as 0, then we get this point on this line as x1, y1, z1. Now say for example, we are given x plus 2 upon 3 equals 2y minus 1 upon 4 equals 3 minus z upon 2. Now this is equation of a straight line, and for this straight line we have to find any one point and we have to find direction ratios of this line. Now here coefficient of y is not 1 and coefficient of z is also not 1. So what we'll do is we'll write this as x plus 2 by 3. Now here we need to make this coefficient 1. So we'll divide everything with 2. So we'll write y minus 1 by 2 upon 2. And here it is this minus 1. So we'll multiply and divide with minus 1. So we'll write z minus 3 upon minus 2. Now here coefficients of x, y and z, they are 1. So direction ratio of this line, they are 3, 2 and minus 2. So direction ratios are 3, 2 and minus 2. And if we put it equals to 0, then we'll get x as minus 2, y as 1 by 2 and z as 3. So a point on this line, it is minus 2, 1 by 2 and 3, and its direction ratios are 3, 2 and minus 2. Now basically there are infinite points on this line. So we can find n number of points using this equation. Suppose we have to find a point in which x coordinate is 0. Now if we put x as 0, we can write this equation as 2 by 3, y minus 1 by 2 upon 2, and this is z minus 3 upon minus 2. Now we can write this as y equals 1 by 2 plus 4 by 3, which is 11 by 6, and then we can write this as z equals 3 minus 4 by 3, which is 5 by 3. So another point on this line, it is 0, 11 by 6 and 5 by 3. So we can put in value of any one variable and then we can get value of other two variables from this equation. Now let us take another question, in which is find the equation of a straight line which passes through the point 1, minus 1, 2 and whose direction ratios are 1, 1 and 0. Now we can write this equation as x minus 1, y plus 1, z minus 2 upon 1, 1 and 0. So this is the equation of this line, and we can also write this equation as x minus 1 upon 1 equals y plus 1 upon 1, and here we can write this as z equals 2. Now in this case, z coordinate doesn't change. So basically this line, it lies in this plane where the value of z coordinate is 2, and this line, it lies entirely in this plane. So there will be questions where you'll be given this equation in this fashion. So there we can write this as z minus 2 upon 0. Say for example, suppose we are given x equals 2y plus 3 and z equals 5. Now we can write this as x minus 3 upon 2 equals y upon 1 equals z minus 5 upon 0. So direction ratios of this line, they are 2, 1 and 0, and a point on this line will be, we put everything as 0, we'll get this point as 3, 0 and 5. We can also write this as x upon 2, y plus 3 by 2 upon 1, and this is z minus 5 upon 0. Now again, direction ratios are 2, 1 and 0, and point here will be 0, minus 3 by 2 and 5. So both the points, they lie on the same line. So these two equations, they look different, but they do represent same straight line. So in this equation, if we put x as 0, we'll get this as minus 3 by 2 y, and this is z equals 5. So we'll get this second point. So choice of point is arbitrary. We can choose any one value, and then corresponding to that variable, we'll find values of other two variables. Now let us take another example. We are given that equation of a line is 2x equals 3y equals minus z, and we have to find direction ratios of this line. Now LCM of 3 and 2 is 6. So we'll divide everything with 6. So we can write x upon 3 equals y upon 2 equals z upon minus 6. So direction ratios of this line, they are 3, 2 and minus 6. So we have to make coefficients of x, y and z 1 before we can write direction ratios. Or we can also write this as x upon 1 by 2, y upon 1 by 3 equals z upon minus 1. So direction ratios are 1 by 2, 1 by 3 and minus 1. And if we multiply this with 6, again we'll end up getting the same result. So if we have a point on this line, and direction ratios of this line, then we can write this equation as x minus x1 upon a equals y minus y1 upon b equals z minus z1 upon c. Now we can also write this equation in vector form. Now in vector form, again, suppose we are given a point whose position vector is a. So position vector of this point is a, and we have a vector which is in the direction of this line, say b. Now we have to find equation of this line passing through a and parallel to b. Now since this a, it is position vector, and this is suppose origin. Now this vector is OA, and any general vector on this line, say P, we can write this OP as XI plus YJ plus ZK, and it is suppose this vector R. So position vector of this point P is R. So we can write this vector AP as position vector of P minus position vector of A, and will be this R minus A, and this vector, it is collinear with B, and we know that two vectors A and B, they are collinear, then A equals lambda B. So if R minus A is collinear with B, then we can write R minus A equals lambda B, or R equals this A plus lambda B. So this is the equation of line in vector form, where this A, it is this point on the line, and B is vector in the direction of a line. Say for example, suppose we have to find equation of a line which passes through this point A, which is I plus 2j minus k, and which is in the direction of this vector 3i plus 4j and plus k. Now here, this is your A and that's your B. So we can write this equation as R equals A, and A in this case is I plus 2j minus k and plus lambda 3i plus 4j and plus k. So this is the equation in vector form. Now we can always interchange this equation from vector to Cartesian and from Cartesian to vector. Now for this equation in vector form, point is I plus 2j minus k. So basically this point is 1, 2 and minus 1, and direction ratios there 3, 4 and 1. So once we have this point and direction ratios, we can always write it in symmetrical form. So it will be x minus 1, y minus 2, z plus 1 upon their direction ratios, which are 3, 4 and 1. And if we are given equation in symmetrical form, say for example x minus 2, y plus 3, z upon 2, 1 minus 1. Now here point is 2 minus 3, 0, and direction ratios there 2, 1 and minus 1. So we can write vector equation of this line as R equals A which is this point. So it will be 2i minus 3j and plus lambda, this direction vector, which is 2i plus j minus k. So we can always write equation from Cartesian to vector and from vector to Cartesian. Now second equation of line is 2-point form. So here we are given 2 points, say A and B. Now this is x1, y1, z1, and B is x2, y2, and z2. Now we have 2 points, and in order to write equation of a line, we need a point and direction ratios. So we already have this point. Now we can write direction ratio of AB, and we know that direction ratio of AB is x2 minus x1, y2 minus y1, and z2 minus x1. So ABC are going to be x2 minus x1, y2 minus y1, and z2 minus z1. Now once we have point and direction ratios, we can write this equation as x minus x1, y minus y1, z minus z1 upon, now this is x2 minus x1, y2 minus y1, and z2 minus z1. So say for example, it says find the equation of a straight line which passes through the point 1, 0, and 3, and this is 5, minus 2, and 7. Now we already have this point. We can find direction ratio of this line. Direction ratios of this line, they are 5 minus 1, 4, minus 2, minus 0, minus 2, and 7 minus 3, 4. Now their HCF is 2. We can divide it with 2 also. So we can write these direction ratios as 2, minus 1, and 2. So now we have direction ratios, and we can choose any one point, either this or the other one. So this equation will be x minus 1, y minus 0, z minus 3, and this is 2, minus 1, and 2. Now if we choose this other point, we can write this equation as x minus 5, y plus 2, z minus 7 upon 2, minus 1, and 2. Now both these equations, they look different, but they represent the same straight line. Suppose we want to find a point on this line in which x coordinate is 3. Now if we put x coordinate as 3 here, we'll get this as 3 minus 2, 1. So it will be y upon minus 1, z minus 3 upon 2. So for x equals 3, value of y is minus 1 and value of z is 5. Now in this case, if we put x as 3, we'll get this as minus 1, and this is y plus 2 upon minus 1 and z minus 7 upon 2. Now here value of y is minus 1 and value of z is 5. So again we'll get this point as 3, minus 1, and 5. So in 3D equation, they may look different if we choose different points, but then these two equations, they represent the same line. Now if we have to write this equation in vector form, then suppose we have 2 points A and B, and suppose position vector of A is A and position vector of B is B, then we can write this vector AB as this vector B minus A. So once we have a point and direction, we can write this equation as R equals A plus lambda B. Now R equals A in this case is A, and plus lambda, and B is symbolic of this direction vector. So it will be this B minus A. So distinction is, if we have this point A and direction B, then this equation is R equals A plus lambda B. But if we have 2 points A and B which lie on this line, then this equation is R equals A plus lambda B minus A. Now this third equation is parametric equation. So at times you'll be given this equation as x equals x1 plus a lambda, y equals y1 plus b lambda, and z equals z1 plus c lambda. So if the equation is given in terms of some parameter, and parameter in this case is lambda, then we say it is parametric equation of the straight line. Now we have to write it in symmetrical form. All we need to do is we just need to find this lambda. Now this is x minus x1 by a. Now from here we can write lambda is y minus y1 by b. So it will be y minus y1 by b, and here it will be z minus z1 by c. So from this parametric equation, we can always write equation of this line in symmetrical form. And from symmetrical form, if we take it equals to lambda, we can write x as x1 plus a lambda, y as y1 plus b lambda, and z as z1 plus c lambda. So we can always change equation of a line from symmetric form to parametric form and vice versa. Now say for example, suppose we are given this straight line which is x equals minus 2 plus 3t, y equals 1 minus 2t, and z equals t by 2. Now we find t from this, it will be x plus 2 upon 3. Now here t will be y minus 1 upon minus 2, and here t will be z upon 1 by 2. We can write this equation as x plus 2 upon 3, y minus 1 upon minus 2, and z upon 1 by 2. And if we are given parametric form, say for example, x minus 1 upon 2 equals y upon minus 1, z plus 1 upon 3. Then if we take it equals to some parameter, say t, then this x will be 1 plus 2t, y will be minus t, and z will be minus 1 plus 3t, which is equation of this straight line in parametric form where t is a parameter. So that's our third equation of straight line. Now this fourth one is line of intersection of two planes. Now in this case, what will be given is, you'll be given equations of two planes. Say a1x plus b1y plus c1z plus d1 equals 0 equals a2x plus b2y plus c2z plus d2. So the question will be, they'll say either this is equation of a straight line, or they'll say we are given two planes a1x, b1y, c1z plus d1 equals to 0, and a2x plus b2y plus c2z plus d2 equals to 0, and we have to find line of intersection of two planes. So if we have two planes, say plane 1 and plane 2. So this is plane 1 and this is plane 2, and they are non-parallel, then they'll intersect each other and they'll intersect in a line. And this is called as line of intersection of two planes. So if we are given two linear equations equated together, then it simply means we are talking about this line which is formed from intersection of two given planes. Now the challenge is to write this equation of line in symmetrical form. Now we know that in order to write equation of a straight line, we need two things: a point on this line and direction ratios of this line. Now what we'll do is, we'll first find direction ratios of this line. Now, if we look at this line of intersection, it lies in this plane P1 because it will be contained in it. And if we look at any plane, then all the vectors contained in the plane, they'll be perpendicular to normal to the plane. So this line will be perpendicular to normal of this plane 1, which is say N1. So angle between this line and this normal will be pi by 2. Now this line, it is also contained in the second plane. So this line, it lies in plane 2 also, and if it lies in this plane 2, then it will be perpendicular to normal of this second plane N2. So basically this line of intersection, it is perpendicular to N1, which is normal of the first plane, and N2, which is normal of the second plane. We have to find direction ratios of this line or vector which is perpendicular to two given vectors, and we have already studied that any vector which is perpendicular to two given vectors, it is given by their cross product. So if direction ratios of this line, they are this vector B, then we can write this B as n1 cross n2, where n1 and n2, they are direction ratios of normal to the plane. So we can write this as ijk. Now here direction ratios are A1, B1, C1, and in this case direction ratios are A2, B2 and C2. Now we'll solve this cross product. We'll get direction ratios as Pi plus Qj plus Rk. So from this we can write direction ratios of this line as sum P, Q and R. Now we have direction ratios of this line. Now we need a point on this line. Now essentially these two linear equations, they'll intersect in a line. So they'll have infinite points of intersection. And from these infinite points of intersection, we have to find any one point. And for this, what we'll do is we'll arbitrarily put value of one variable as 0 or any other value which you like. And then we can solve the linear equation to find values of other two variables. Now say for example, we can put x as 0. And if we put x as 0, we'll get this as b1y plus c1z plus d1 equals 0 and b2y plus c2z plus d2 equals to 0, which are two linear equations in y and z. Now we'll solve them. We'll get solution to them as y1, z1. So one of the point on this line will be this 0, y1 and z1. So once we have point and direction ratios, we can write equation of this line in symmetrical form as x minus 0, y minus y1, z minus z1 upon P, Q and R. Now say for example, we are given a straight line which is 2x minus y plus z minus 3 equals 0, and is 3x plus 2y minus z plus 1 equals 0. Now we have to express this line in symmetrical form, or we have to find line of intersection of these two given planes. Now first we'll find direction ratios of this line, and direction ratios, it is given by this cross product ijk. Now direction ratios of this normal, they are 2, minus 1, 1. And here direction ratios are 3, 2 and minus 1. Now we solve this determinant, we'll get this as 1 minus 2. So it'll be this minus I, and then it'll be minus 2 minus 3 plus 5j. And then it'll be this 4 plus 3, 7 plus 7k. So direction ratios of this line of intersection, they are minus 1, 5 and 7. So we have found direction ratios of this line of intersection. Now we need to find any one point, and for this we can arbitrarily choose one value. So let us choose x as 0. Then we can write minus y plus z minus 3 equals 0, and if we put 0 here, we get 2y minus z plus 1 equals 0. Now if we add them, we'll get y minus 2 equals 0, that is value of y is 2. And if we put y as 2, we'll get z as 5. So one of the point on this line, it is 0, 2 and 5. Now once we have this point and direction ratios, we can write equation of this line as x minus 0, y minus 2, z minus 5 upon their direction ratios, which are minus 1, 5 and 7. So this is the equation of line in symmetrical form, or this is the equation of line of intersection of two given planes. Now fifth one also is equation of line of intersection of two planes, but in this case the planes given, they'll be very simple. So there'll be two simple linear equations. Say for example, we are given, suppose x is sum ay plus b and z is sum cy plus d. Both these equations, they are linear equations in x, y and z. So both the equations, they represent a plane, but in this case we have only xy and here we have only z and y. So we can find y from this. We can write x minus b upon a equals y, and we can also find y from this. So we can write y equals z minus d upon c. So we can write this equation as x minus b upon a equals y upon 1 equals z minus d upon c. So this is the equation of this line in symmetrical form. So here we don't have to take cross product and find point. We can write the equation of this line directly. Now direction ratio of this line, they are a, 1 and c.